And here we are at our presentation right here. For those of you guys just joining me on the video, I'm recording from Chapter 2, and we're going to use information about the mean, median, and mode, as well as standard deviation to help us interpret data in an Excel data problem. And here's the problem. This is problem number 2 from our web assigned problem. It reads as follows. A music school has budgeted to purchase 3 musical instruments. They plan to purchase a piano that costs $4,000, a guitar costing $550, and a drum set costing $650. We're told that the mean cost for a piano is $4,500 with a standard deviation of $2,000. Likewise, the mean cost for a guitar is $450 with a standard deviation of $200, and the mean cost for the drums is $950 with a standard deviation of $125. So we want to interpret this information and try and figure out something about what the standard deviations are telling us. In other words, how many standard deviations above the average cost is the piano? So let's take a screen capture of this information right here, and let's use it. So I'm going to copy that image right here. Let's go to our whiteboard, and let's take that information up here. Let's see what we can do with it. All right. So let's talk about the pianos for a moment right here. One of the things that we're told is that the piano costs $4,000, but the mean cost of our pianos is $4,500. So what we're going to do is we're going to think about a number line right here, and I'm going to erase that line. That was a terrible line. Let me see if I can draw a better line right here. Better number line. There we go. Didn't like me here. Hold on, give me one moment. Let's try this. That's a nice line. Okay, here we go. And I'm going to make it a line while I'm standing here for our drum set. We'll try that again. Let's see if we can make it nice and straight this time. And for our guitar. So got 3 number lines going right here. Sometimes that first line doesn't come out the way I like very well. Okay. So with our piano, let's think about it this way. We've got, on average, for pianos, it says the cost is $4,500, but that the standard deviation is $2,000. So if we think about that standard deviation as telling us sort of about an average distance away most of the data is, that means that most pianos will cost between, let's see, $4,500 plus $2,000 would be $6,500. And $4,500 minus $2,000, that's $2,500. So our piano, the one we want to purchase for the school, costs $4,000 right here. And we can already see that it's below the average. The question is, how far below the average? Well, we can actually calculate that here. Let's go to our problem right here. Let's talk about the piano. So how many standard deviations? How will we figure that out? Well, here's how we figure that out. What we're going to do is that we're going to use something called a z-score or a standard score. And the way the z-score works is this. Get my pen working here. The way the z-score works is this. In a z-score, we're going to take the difference between the cost that we have minus the average cost. So it's always our value of whatever the variable is minus the mean, and we're going to divide that by the standard deviation, right? Because if you think about it, what they're saying is that, all right, if this is our average right here, our average number for 4,500, this is plus 1 standard deviation to the right, and if the price is below, we're at a negative standard deviation. We're saying we're minus 1 standard deviation below the mean, right? So we want to find out, well, how far is this? Well, this is going to be negative 500 over 2,000. Now if we do the fancy mathematics right here, 500 divided by 2,000 as a fraction, that's the same thing as saying 5 over 20, negative 5 over 20, and that's saying negative 1/4, which as a decimal happens to be negative 0.25. Okay. What this problem says is that, well, the cost of $4,000 is 1/4 of a standard deviation less than the mean. So that's what we enter in our problem right here. We say we are 0.25 standard deviations below the average, right? So our standard deviations, that's the ratio between the change in our cost minus the average divided by the standard deviations, the number of standard deviations in our problem. So let's go back. We're told next that we want to figure out something about the standard deviations for our guitar cost. So let's go back and look at our guitar cost right here. We're told that in the problem right here, the average guitar costs, what is our average guitar cost? $450. Right, $450, and the standard deviation of that is $200. So this looks almost kind of spooky, like our above standard deviation, except we're in the hundreds instead of the thousands, right? So anywhere between 250 and 650 is considered within a standard deviation of the mean, right? So adjusting my pen here a little bit. If this is our average right here at 450, this is plus 1 standard deviation to the right. This is considered minus 1 standard deviation. We always use a minus if we're going to the left. We always use a plus if we mean going to the right. And we get a z-score. So the guitar we want to buy costs $550. Well, let's think about where that 550 is in relation to the rest of our data right here. 550 is, looks like it's right about here in the middle between our 450 and 650. But I'm suspecting that's about a half of a standard deviation to the right, but let's check that out. We're going to take 550 minus 450, and we're going to divide that by a standard deviation of $200. Well, working that out, 550 minus 450 is 100, positive 100, over 200, and sure enough, that's equal to the fraction 1/2, or 0.5. So it's a positive number. So we're going to say that that positive number is going to be our number of standard deviations to the right. So 0.5 standard deviations above the average. Right? How about this one? How many standard deviations above below is our average drum set? Well, we can almost do this without the number line, but I'm going to illustrate on the number line anyways, simply because it makes a lot of sense to me when I see it. So right here in our drum set, our drums, well, how much do our drums cost? Our drums have an average cost of $950, so $950, with a standard deviation of 125. Oh, okay, a little bit more addition and subtraction needed, but let's see. If we add $125 to 950, we're at $1,075. And if we take away $125 from 950, we are at $825. All right, so the drum set we want to buy costs $650. So that's, wow, well, let's see, let's take a look at that. That's way over here, right? 600 might be way down here, right? Where here's our average drum cost. Our 800, we had 950, so if we subtract one standard deviation, that is $125, we are at $825. And if we add one standard deviation to the right, we're at $1,075. So to find the z-score, what we're going to do is that we're going to take the difference between our $600 minus our average of $950, and we're going to divide that by the standard deviation of $125. Now you're going to have to forgive me that my fraction work is not as good as I'd like sometimes, but 600 minus 950 is a difference of negative $350, and we're dividing that by 125. So this time I'm going to get out my handy dandy calculator here. There it is. And we're going to take our 600 minus 950, which is negative 350. We're going to divide that by 125, and we get negative 2.8 in this case. So our cost is negative 2.8 standard deviations, and that is standard deviations to the left. All right, so going back to our problem right here, what are we saying? Well, in this problem, we're going to have to enter in the number 2.8 standard deviations below the average. So, which is the lowest cost when compared to the other instruments of the same type? Well, clearly, when we have a standard deviations that is below the average, we've got a cost that's less. And of the two, well, the drum set is clearly way less than the average. Which is the highest as compared to the other instruments? Well, any cost that's above is going to be higher than the average. And of course, the only one that's really the highest is our piano. So there we go. There are our answers for problem number 2 on the WebAssign problem.